Hello everyone, my name is Shalini, student of SVCE. In this video, I'll be covering some concepts of database management system. Those are entity types, entity sets, attributes, roles, structural constraints, and weak entity types. So in the contents, we have introduction to database concepts, entity types, key characteristics of entity types, entity and entity sets, attributes and attribute types, types of attributes in DBMS, relationships and roles, structural constraints, weak entity types, representing weak entities in the database, advantages of weak entities, conclusion. Starting with the introduction to database concepts. Databases are powerful tools for organizing and managing large amounts of data. They provide a structured way to store, retrieve, and manipulate information, making it easier to access the data you need when you need it. Entity types in database management system. An entity type refers to a collection of entities that have the same attributes. It represents a real-world object or concept that can have a distinct existence and is identifiable in the domain of the database application. Each entity type is typically represented by a table in a relational database. Example, student. By the way, we have key characteristics of entity types. Attributes. These are the properties or characteristics of the entity type. Each attribute describes some aspects of the entity. Entity set. This is a collection of similar types of entities. For example, all records of students in a university database form the entity set student. Primary key. This is a unique identifier for each entity in the entity set. It ensures that each entity can be uniquely distinguished from others. Relationships. These define how entity types are related to one another. For instance, a student entity type may have a relationship with a course entity type through an enrollment relationship. Entity and entity sets. Understanding entities. An entity type represents a real-world object or concept, such as a person, a product, or a location. Each specific instance of an entity type is called an entity. Defining entity sets. An entity set is the collection of all entities of a particular entity type. For example, the customer entity type as an associated entity set containing all customers. Uniquely identifying entities. Each entity within an entity set must have a unique identifier known as a primary key, which distinguishes it from other entities in the set. Attributes and attribute types. Attributes. Attributes are the properties or characteristics that describe an entity. They are the fundamental building blocks of a database, providing the detailed information needed to represent real-world objects. Attribute types. Attribute types define the kind of data that can be stored for an attribute, such as numbers, text, dates, or times. Common attribute types include string, integer, float, boolean, and date type. Next, we have types of attributes in DBMS. There are 8 types of attributes, which are simple attributes, composite attributes, single valued attributes, multi-valued attributes, derived attributes, complex attributes, key attributes, and stored attributes. Simple attributes. Simple attributes are those that cannot be further divided into sub-attributes. For example, student's roll number or employee identification number. These attributes are usually assigned by an organization and are used to identify an individual within that organization uniquely. Databases and other systems often use simple attributes to track and manage information. The first figure represents the simple attribute. Composite attributes. Composite attributes are made up of 2 or more simple attributes. For example, a person's address may be a composite attribute that is made up of a person's street address, city, state, and zip code. Composite attributes can be used to create more complex data models and can be helpful when trying to represent data in a concise way. The following figure shows the representation of composite attributes. Single valued attributes. Single valued attributes can only have one value. For example, a person's social security number is a single valued attribute. Social security numbers are used to uniquely identify individuals in the United States and are therefore single valued attributes. Multi-valued attributes. Multi-valued attributes can have more than one value. For example, a person may have multiple email addresses or phone numbers. Multi-valued attributes in DBMS are often used to store information about relationships between entities. For instance, an employee entity might have a multi-valued attribute called dependents that stores the names of the employee's dependents. Multi-valued attributes can also be used to represent hierarchical data. Derived attributes. Derived attributes are based on other attributes and are not stored directly in the database. For example, consider a database of employees. Each employee has a date of birth, and we might want to calculate their age. However, age is a derived attribute because it can be determined from the date of birth. Here is an example diagram of a derived attribute in DBMS. Next, we have complex attributes. The complex attribute in DBMS involves both multi-valued and composite attributes. For example, someone might have more than one house and each house might have more than one phone. The phone is then considered a complex attribute. Key attributes. Key attributes are used to uniquely identify each row in a table. Usually, there is more than one key attribute in a table, primary key and foreign key. For example, in a table of employees, the employee ID would be the primary key, while the manager ID would be the foreign key. Stored attributes. Stored attributes are the data that remain constant and fixed for an entity instance. These values help in deriving the derived attributes. For example, consider a customer entity in a bank. The customer's name, age, and address would be stored attributes. The customer's account balance, a derived attribute, could be calculated based on the transactions, another stored attribute associated with the customer. Next, we have relationships and roles. Relationship types. Databases capture different types of relationships between entities, such as one-to-one, one-to-many, and many-to-many. Relationship roles. Entities play different roles within a relationship, like employee and manager, or customer and order. Entity participation. Relationships define how entities participate, like whether a relationship is mandatory or optional for an entity. Structural constraints. Entity relationships. Structural constraints define the valid relationships between entities, ensuring the integrity and consistency of the database. Keys and identifiers. Constraints specify the unique identifiers such as primary and foreign keys that distinguish entities and govern how they can be linked. Cardinality constraints. Constraints determine the allowed number of instances in a relationship, specifying if it is one-to-one, one-to-many, or many-to-many. Weak entity types. Dependent existence. Weak entity types cannot exist independently and must be associated with a related strong entity type. Partial key. Weak entity types have a partial key, which is an attribute or set of attributes that helps identify instances within the same owner entity. Identifying relationship. Weak entity types are identified by an identifying relationship with their owner's strong entity type. Multiple owners. A weak entity type can have multiple owner entity types, creating a more complex database design. Representing weak entities in the database. Weak entities are represented in the database by associating them with a supporting or identifying entity. This creates a one-to-many relationship between the identifying entity and the weak entity. The primary key of the weak entity is composed of a primary key of the identifying entity plus an additional attribute or set of attributes that uniquely identifies the weak entity instance. Advantages of weak entities: efficient storage. Weak entities allow for more efficient data storage by eliminating the need to duplicate information across multiple tables, saving valuable database space. Enhanced querying. The ability to query weak entities alongside their identifying relationships enables more powerful and precise data analysis, unlocking deeper insights. Improved data integrity. By tightly linking weak entities to their identifying relationships, the integrity of the data is enhanced, reducing the risk of orphaned or inconsistent records. Flexibility. Weak entities provide more flexibility in database design by allowing the creation of complex relationships that capture real-world scenarios. Conclusion. In conclusion, properly defining entities and their attributes, along with identifying weak entities and their dependencies, lays the foundation for a robust database design. This ensures data integrity, reduces redundancy, and improves the efficiency of database operations. Understanding these concepts is essential for anyone involved in database management and design, as they are fundamental to building scalable and maintainable database systems. Thank you.